Start.
Okay.
Mom. Hey, happy birthday ya mama. Hii umekula yote.
Sisikii kitu.
Hello. Hello.
Hello.
Okay, I think we can start, eh?
Okay.
Okay, so I think we'll let's just revisit the notes. So, okay. So I've opened many windows. Let me just see which one. Okay, so I think we can go to this one. We were trying, I think last week, last time we just focused mainly on air pollution. And we were looking at the various pollutants of air. And you identified carbon monoxide, nitrogen oxide, and the oxides of nitrogen. And then we finished with sulfur oxide. And we say the sulfur oxides normally cause what we call acid rain. And there's something that we were talking about, the effect of nitrogen oxide. It causes what we call photochemical smog. I don't know if we can be able to see it here. So sometimes in the developed countries, you can have situations like this one. I don't know if you can be able to see it from your end, where the atmosphere doesn't look very clear. So this is what we are saying, smog. We said smog is taken from two words, smoke and so I think it is smoke and fog. So the atmosphere becomes foggish, but the foggish color is brownish because of what we call photochemical reaction. Now, one of the causes of this smog, the brownish color, is because of the presence of nitrogen dioxide. It's one of the chemicals that form a smog. So what we normally, so in terms of formation, nitrogen oxide also plays an important role in the formation of this, plus some organic matter. So sometimes in terms of the equation, I think I'll give you this addition notes on formation of smog. So we have opened many windows. Let me just go back and so when you talk about smog, the formation has about 6 equations. It involves the organics, nitrogen oxides, and ozone. So those are the things that play key role in the formation of photochemical smog. So there are about 6 equations that we need to know. So in the formation of this smog, we say nitrogen oxide plays a very important role. So the first equation during the formation of smog is that nitrogen oxide, which is emitted from the various combustion process, this is what we said, combines with oxygen to form. So it forms nitrogen dioxide, and then this nitrogen dioxide, again, in presence of UV light, breaks down to form oxygen plus nitrogen monoxide. So it's just like a reaction repeating itself. So the brown color that you saw in that smoke is because of this nitrogen oxide. So when it breaks down, it gives nitrogen monoxide. And this oxygen radical that is formed here can combine with oxygen to form what we call ozone. So again, you can be able to form ozone from this oxygen just by it combining with molecular oxygen. So in this second reaction, we are seeing that the oxygen, which is formed from a breakdown of nitrogen monoxide, combines with oxygen molecule to form ozone. And for this kind of reaction, a variety of molecules can ozone can react, oxygen can react, sorry, ozone can react with nitrogen monoxide to form oxygen gas plus nitrogen dioxide. So this becomes our second equation. And then in the third reaction, which normally occurs in the evening when there is no light, in this reaction, the ozone, so in this particular reaction, what happens is that the oxygen combines with the organics to form aldehydes, which can be further oxidized to peroxides or perioxide. So here we are seeing after you have formed the nitrogen dioxide in the third reaction, in the evening, you could have another fourth reaction occurring. So during this fourth reaction, what happens is organics, which you are representing as RC, combines with oxygen to form aldehydes, which can be oxidized further to form what we call a peroxide. So when the RCO means it's a compound of carbon, maybe hydrogen and oxygen, and this generally refer to them as aldehydes. And these compounds can even undergo further reactions to form what we call peroxide radicals. So you can again form peroxide radical during this particular reaction. So here we are now seeing, so in the fourth reaction, now we are seeing the introduction of organics. And that's where we said the volcanics also play a role, the organics. They play a role in the formation of this. And then whatever you get here can be oxidized further to form. And then in the last reaction, we have now oxygen combining with the peroxide radicals, as demonstrated here. Reaction, which we get from this, the nitrogen monoxide combines with the peroxide radicals to form nitrogen dioxide, which is the one that gives the brown color. And this nitrogen dioxide will go on to form more ozone. So again, if you are asked about photochemical smog, we'll need to know about these 5 equations. that play an important role during the formation of that smog. So smog in itself, we are saying, is a mixture of nitrogen dioxide, the organics, and ozone. And the formation starts from the first reaction. Nitrogen oxide is oxidized to form nitrogen dioxide, but we have said in the presence of UV light, this one breaks down to form atomic oxygen plus nitrogen monoxide. And then in the second reaction, the atomic oxygen combines with molecular oxygen to form ozone. And then the so this reaction with ozone. And then after we have formed ozone in the second reaction, in the third reaction, the ozone now combines with NO. And this normally happens in the evening light to catalyze the breakdown of nitrogen monoxide to generate that. So nitrogen monoxide, so ozone will combine with NO in the evening to generate oxygen gas plus nitrogen dioxide. And as it has been mentioned here, during the formation, the third reaction, what happens is that the concentration of ozone will drop. The concentration of ozone is dropped because we are using ozone to react with NO, and then we are generating more oxygen and nitrogen dioxide, which gives rise to that brown color that we are seeing. In the fourth reaction, now we introduce the organics, where the atomic oxygen combines with organic, which are oxidized further to form the peroxide radicals. And these peroxide radicals react further by reacting with oxygen to generate organic radicals. And then the final reaction during this equation is where NO now reacts with the peroxide radicals to form nitrogen dioxide and more organics. So the color that we see there that we were trying to show was because of the evening reactions, which just shows how ozone is formed. So that's how ozone is formed. So when you see when you talk about smog, so we talk about smog, we are talking about an atmosphere which is not very clear. So you can see here, you might think it's evening, but this is just during the day because of polluted environment. So this one is very common in developed countries where there's a lot of industrial works. And we can also be able to explain the same in many ways. So when you have a lot of these nitrogen oxides, they play an important role in the formation of this photochemical smog. So in cities, in developed countries, the atmosphere may not be very clean because of formation of ozone, which we have just explained, that is formed because of the reaction that we have talked about. So you'll get atmospheres which are not very, sorry, it's like I've lost you people. It's like it was not sharing that window. So I was talking about atmospheres like this developed. I think I think it is evening, but this is a phenomenon which is seen during the day in some countries because of a production of too much nitrogen oxides. So when they react with ozone, you'll end up getting a environment which is not very clear. Let me just close some of these windows. So you'll get environments which are not clear because of smog, what we call smog. So basically, that's what we mean when we were talking about the formation of photochemical smog last time. This is what we were referring to. So I'm just trying to reinforce what smog is. I'll just give you this information in form of notes, and then just as we try to build up on what we said. there is something that I wanted to bring on board. I think we might have talked something about acid rain. I'll send you this information. Let me see if I have something here on acid rain. Acid rain, acid rain. Let me see here. Okay. Let me just share the screen again. Okay, so I think we can have some extra information here that we can share. I think just to review what we had said about pollution. So it said you can have mainly this type of pollution: air, water, land, soil, and noise pollution. And then there are also other forms from sewage. This one will affect normally the water. And when we take the water will not be safe for consumption. So remember, we said a pollutant is anything that will cause adverse effect on a human being and maybe his activities. But a contaminant can just be present without causing any effect if it is more than what we required. So like there's been a concern about the sewage and wastewater. So domestic, household, industrial, and agricultural practices normally produce a lot of wastewaters, and this can cause pollution of many lakes and waters. So for sewage, it's a term which is used for wastewater that is often contains fecal waste, urine, and laundry. So we can get this from the laundries. And then, so the problem that we normally have in the world is how to treat this sewage water. And when you see these big cities, they normally have sewage treatment plants, which allows for the recycling of the water. So I think this is also something that is a concern as far as the environment is concerned. So disposal this outbreak in major cities, and the priorities of most cities is to see how to recycle to clean the sewage water and reuse it. So when they are not treated, they normally contain a lot microorganisms, and these microorganisms can cause diseases. Quickly and hygienically through sewage pipes, and then they are normally regenerated. So for the sewage, the advantage about them, most of the products are biodegradable. So we have got what we call biodigesters, which can be able to break down this sewage waste into friendly products like methane, which can be used for generation of energy. But for developing countries, this one is still a problem. But when you go to major cities, this one is still a problem. So the waters that people drink, they are normally contaminated, and there are cases of these airborne diseases in these cities. So, so that is one of the aspects when you talk about water pollution. We also consider that sewage waste. So the issue here is how to manage the waste from the sewage or the sewage waste. And then we have industrial water, and also as a major form of pollution. So we know some of these industries, water is normally used a lot to clean the product or to clean the raw material before use, and even the product during some sections to remove the unwanted product. Like if you're talking about the tanneries, we talk about companies that make tannin, from skins and other products. They normally use a lot of water to clean, and so also some chemicals to bring about the color. So again, this is also a major problem because the water that comes from the industries normally contain a lot of chemicals. Like if you're talking about the textile industries, you can talk about the organic dyes, which are used to color the materials. So these ones also, they flow through the wastewater, and if they are not checked before accessing the seas and the oceans, then they are likely to pollute the water. So some of the pollutants that you can get from the industries may also include heavy metals, and some of them could be, I think we talked about asbestos. This was used before, but now it has been solved because it is carcinogenic. And then we have some metal industries, like when you're recycling batteries. I think we talked about this. There was a case in Mombasa about lead poisoning because people were staying near a factory which was recycling lead, the lead batteries. And this one has been known to cause health problems. The problem with these metals is that they are normally non-biodegradable, so they can stay in the atmosphere for a long time, contaminate, and cause an harmful effect to both human beings and even plants. The problem with these metals is that when they are taken in by human beings, they interfere with the physiological process, because we know enzymes. Those of us who are doing biology, when you talk about enzyme, the active sites in these enzymes are metals. So when you bring in these metals, they normally replace the active metals, which are normally zinc and the copper. And when they replace those metals, they render those enzymes to be inactive. So that's why when people normally talk about lead poisoning, we talk about lead precipitating proteins, which are just enzymes. The other metal, which we also know, which is not friendly, is mercury. So this one can also come from industrial waste. And it's a metal which has been known to be harmful to both humans and also plants. There are cases where it has been reported having gotten into human beings through the meeting, maybe a product from the water like fish and seafood. And the major cause of mercury causes cancer. So these ones, they cause cancer because they interfere with the DNA and formation of the genes. So they can cause what we call mutation. And then from, again, the industrial waste, you can also get the nitrates and the phosphates. So these nitrates, phosphates, you can get them from pumps that are make fertilizer. We talked about ammonium nitrate, potassium nitrate, calcium nitrate. And when you have an excess of these nitrates, they'll find themselves in the rivers and the lakes. And we say the effect of this is that they cause eutrophication, which is a problem in marine environment. Eutrophication, when you have too much of these nitrates in the water, they'll cause the planktons to overgrow, just like we had the problem of water hyacinth. When you have too much of these plants in water, they'll tend to compete with oxygen with the aquatic creatures like fish, and this might lead to suffocation of the same product. Phosphate, the same thing. It can also cause eutrophication. When you have excess nutrients, the planktons or plants which grow in water, they grow very fast, and the population might, when the population is too much, then they might affect the aquatic creatures. And then the other product that can also cause pollution is sulfur. It's an unmetallic substance, but it's also harmful when it is used in excess. And then we know the other source of pollution from industry could be oil. So oil normally pollutes the water through accidental leakages or from products from the industries. And the problem with the oil is that it doesn't dissolve in water. So what happens is that when you have oil, it forms a thick layer on the surface of the water. And when you have that thick layer on the surface of the water, it will affect the aquatic creatures in two ways. Number one, you may not have enough light entering the sea, and photosynthesis may not be effective. Again, when you have this oil, it also affects how oxygen dissolves in water. So it will affect how oxygen dissolves in water, and therefore, because of this, it can be harmful to both fish and birds that live, creatures that live in the water. Then we have petrochemicals from gases, petroleum. They can also be toxic to water. So for the oil production, I think as we have said, you could have spillage, you could have runoffs, and just people dumping the same in the water. And this one has been known to cause about 25. So this one, oil spills has been found to cause about 25% of the oil pollution in the ocean. So the rest could come from maybe ship when they travel over the water. You could have some of the oils leaking through the water, and this can cause a severe problem. And we have just said the major problem is that it doesn't dissolve in water, so that makes it a big problem. And then we have also, sometimes in the atmosphere, we can also have solids. So we talk about atmospheric deposition. Sometimes we have particles in the atmosphere, which can mix with carbon. They can mix with carbon monoxide, nitrogen dioxide, and form what we call acids, as we said. So the air pollution, when we talk about air pollution, it means that the water vapor, which is in the atmosphere, can absorb most of these gases. And when it absorbs most of these gases, because the gases are non-metals, they form acids. And when the rain falls, it falls as acid. And this is likely to affect the ecosystem. So in terms of just a brief summary of what can cause the marine poisoning or pollution, not poisoning, sorry, we have things like cardboards, and you'll see that the problem with these things, they take a long time before they degrade. That's why sometimes last year, sometimes back, the government banned plastics because they are not biodegradable. They stay for a long time in the atmosphere before breaking down. So we have things like cardboard. Cardboard may not be a pollutant as such, but it's a contaminant because it can cause a menace by blocking drainages and so on and so forth. And you can see the time that it takes for it to break down, 2 weeks, paper, 6 weeks. The other materials for packing photogradable materials, those ones, they take about 6 weeks. Things like foam that we get from soap and others, they can stay for quite a lot. Sometimes some even take that are used to make mattresses, they can take even 50 years. So we have metals like aluminium, 200 years, plastic packages, 400 years, and this is why they were trying to discourage the use of the same. Glass even takes longer. We are lucky that in our country we don't have nuclear waste, but there are other countries where we have nuclear waste, and this nuclear waste can also be harmful because some of the radiations which are generated are not friendly and can cause cancer. So I think we don't have much of that. And then for the tanks, we can have so for the tanks, we can have what we call leakages. So I'm just trying to wrap up what we said last time. And then we talked about global warming. This is because of excess carbon dioxide. When we have excess carbon dioxide, it can cause global warming. And that's why we are encouraged to plant more trees to avoid a global warming. We'll still revisit this one, the global warming. So this, we had talked about the acid rain. And I just wanted to mention something about this acid rain. What do we mean when we say acid rain? So acid rain is any form of precipitation. That means precipitation means the water vapor goes into the cloud where the temperatures are so low, it will precipitate. And if the density of that the precipitate becomes greater than that of the air, it's going to fall down. And now as it falls off, it will pass through the atmosphere and reaching places where temperature is high, the same will be forced to melt and fall as water. So if we talk about acid rain, we are talking about rainwater that has has mixed with the acidic gases, like sulfur dioxide, nitrogen dioxide, and we know this water will contain hydrogen ions. When they break down, they contain hydrogen ions. So normally they'll have low pHs. And excess, we say the excess amount of sulfur and nitrogen from combustion of fuel can generate nitrogen dioxide and sulfur dioxide. And when this sulfur dioxide combine with water, then you are likely to form the acid rain. So sulfur dioxide is indicated here, nitrogen dioxide, when they combine with water, they form the oxide, and they form the acid, and when this acid falls, then it's likely to cause damages. So we have a schematic diagram here, which shows what happens. So from the volcanic activity, natural activities, where you have industries and so on and so forth. So we have, you can generate sulfur dioxide, you can generate nitrogen dioxide, and this can go into the atmosphere. So this one can go into the atmosphere, and when they go into the atmosphere, the gases, they go there as dry deposition. So they go there as dry deposition, the gases, and when they mix with water, when they mix with water, they can be able to mix with water in the atmosphere. And when they mix with water, what will happen is that they'll form pollutants in the cloud with water. And when precipitation occurs, that means when rain falls, the wet deposit that comes, that falls, will fall as acid rain. So the wet deposition is what we refer to acid rain. So we have dry depositions without water, wet deposition with water. So what are some of the effects of the acid rains? I think I've just tried to explain the effect of this acid rain. And the effect of the acid rain is that it's going to make the water to be acidic. And we know most of the organisms are sensitive to pH because the reactions in the bodies are controlled by enzymes which are sensitive to pH. And then also, we also need to know that when you have these acids, they're normally corrosive or irritating in nature. So when you have too much, when the pH is a bit low, then it's likely to affect the creatures which are living in water. So we talk about chronic acidification, which might also affect the uptake of nutrients, and this in turn may affect the aquatic system. So it has a lot of effect. So for water, for the creatures in water, they can it can affect them through what we call chronic acidification, and this one is normally caused. It affects the uptake of nutrients over time, which might weaken the bones. Because when you have low concentration of calcium, then it will affect the formation of bones. For the plants, of course, calcium will also affect the same because it's used during the metabolic processes. So this one is possible. And then for plants like the forest, the same can also happen. It has been known that when you have too much acid, the acid can affect the leaves. We talked about chlorosis. And when you affect the leaves, then you also affect the formation of the nutrients. Too much of the acid also will increase the uptake of aluminium, and aluminium has been known to retard the growth of the growth of plants. So I think I'm just brushing through this just to see the effect of these acid rains. And sometimes when we inhale the same, it can also corrode the air pipes, and this can cause disease associated with the air pipe and the lungs. And if it reaches, if it goes into the body, then it can also affect the other organs like the heart, the heart, because of the too much acid. Now, for the buildings, we talked about this. When the environment is so acidic, then what we are likely to have is we are likely to destroy the structures, like the walls, which are made of calcium carbonate, the roads also. If they are made of cement, then most likely they'll be affected by this acid rain. And then what can also happen is when you have too much acid and you have these monuments, these nice things which are made from metals like iron, they are likely to be corroded. I think there's a time the government has started what we call beautification of cities by building structures that may be of monumental importance. And this was when they combine with acid, they get corroded. So I think we have just I've just tried to explain here what happens for buildings. If it's made of calcium carbonate, the calcium carbonate will react with the acid formed. In the process, you form salt plus CO2 plus water. So it will destroy the structures. So what are the solution to acid rain? Now, for us to reduce the effect of acid rain, what we need to do is to decrease the source of sulfur dioxide. Decrease the source of sulfur dioxide, nitrogen dioxide. How do we decrease that one? So I think we talked about some things last time. We can say we talked about having what we call catalytic converters in engines, which converts the NO and SO into friendly products. We also talked about using alternative source of fuel. We talked about electric cars. You can also use solar instead of using the fossil fuel. Or sometimes we have what we call instead of each person driving a car, people can combine. People can combine use of public transport, or maybe car hiring, so that you have a few of these products being produced into the atmosphere. And then the other way of controlling this is also by, for industries, we have got what we call long chimneys, and in those long chimneys, they normally put lime, which is just calcium oxide or calcium hydroxide. So when you generate these gases, like sulfur dioxide, they'll be absorbed by the calcium hydroxide to form calcium sulfate. I think this was, they are called scrubbing or something, yeah. So that one will affect, that one will prevent the introduction of sulfur dioxide into the atmosphere. So I think, so this section just talks about smoke, what we have just mentioned, how they are formed, the peroxides, and so on and so forth here. Yeah. So I think maybe to get back to where we were, so to get back to where we were in terms of the notes, let me just see again. Okay, so I think we had talked about the gases. I was just trying to remind ourselves about what we learned last time. I'll give you those other materials later. So I think this is where we were about the gases and their effects. I don't know if there's any question on this. So this one is just showing the effect of liming. When you add lime, the calcium hydroxide will combine with the sulfuric acid to form calcium sulfate plus water. So liming just dissolves the acid and And by dissolving the acid, you are able to take care of that. So when you have liming, we talked about calcium. When you have too much calcium, it's not good for the plant. So liming can also dissolve calcium, making aluminium, making it insoluble. And then I think the other effect of acid rain, we said, was it can corrode pipes. And the solution to that, instead of using metallic pipes, we can use now the plastic pipes. So I think that's what I wanted to mention about the acid rain. I don't know if there's any question up to there. Okay, so maybe we could briefly talk about the particulate matter. When you talk about particulate matter, these are we're talking about particles, very small particles, which can act as aerosols or suspensions in the air. So they are normally suspended in the air, and they are normally very small particle. They could be in solid or even liquid state, and their diameter is normally very small. So despite their small size, they have been known to cause several physical and chemical effects and physiological effects in the environment. I think you have just talked about photochemical smog, which also contains these particles that you are talking about. So they're divided into two. So we have the primary and the secondary. So for the primary ones, as we said before, these ones are injected directly into the air through physical or chemical means, and they can include pollen grains, the soil, the dust, the volcanic debris from volcanic processes, tornadoes, storms, and so on. And then we also know that we also have these cement making factories during the formation of cement, because they normally crush rocks. In the process of crushing this rock, some of these particles might disappear into the atmosphere. And then from the car's exhaust, if the fuel is not burned completely, then instead of getting carbon dioxide and carbon monoxide, you'd end up getting carbon particles. And these ones are likely to affect, to contribute to this particulate matter in the atmosphere. So for the secondary particulates, so these particles are produced as a result of the primary ones reacting. And we just saw a few. So when you react, whatever you have produced, you can get other particles. Like we said, if you have sulfur dioxide, you can get sulfates. If you have nitric acid, you can get nitrates. And sometimes from the organic, you can also get hydrocarbons. So what are the harmful effects of these particles? The major effect of these particles is that they can affect the respiratory system, because when they are inhaled, sometimes they can come along with bacteria and other harmful things, and this might affect the lungs. So some of the effects of this will include they can affect the respiratory system, and when they affect the respiratory system, they can affect the breathing, and you'll find people now suffering from shortness of breath due to the blockage of the alveoli. Alveoli, these are the structures in the lungs that help in the gaseous exchange system. So when the surface is not clean, it will affect the diffusion of oxygen, and it's likely to cause a suffocation. And then some of these particles could contain the asbestos. And when you breathe in these fibers, they can be dangerous because we say they are carcinogenic. Sorry, I think my screen is not sharing. Sorry, I think it was not sharing. So I think what we are saying, we are talking about the particulate nature. Sorry, it wasn't sharing. So we are saying that two types. You can have primary or secondary. So primary are injected directly into the atmosphere. The secondary ones are generated after the primary ones have undergone some reactions. Just like we have primary pollutants and secondary pollutants. Primary, we get it directly from the source, get some reactions involving the secondary pollutants. Particles can be harmful. How can they be harmful? We have said they can, when they are inhaled, they can affect the lungs, and also the gas tract. And because of the particles, when they land, when they are deposited on the surface of the lungs, they'll interfere with the diffusion of gases in and out of the lungs, and this is likely to affect the breathing. So you'll find some people, they suffer from shortness of breath due to the blockage of the alveoli, which I've just said are responsible for gaseous exchange. And then the particles can also contain things like asbestos. When these are inhaled, because they are dangerous, they can cause cancer. And the other thing is they can also cause irritation when they are inhaled in the gaseous trap. They can cause irritation because some people feel uncomfortable when you have something sitting in the gas pipe. So I think so we have that, and then of the particular nature, some of them could be organic in nature. So we have got what we call PAH. These are just called polycyclic aromatic compounds. So these are aromatic compounds. These are organic compounds, and some of them have also been known to occur in nature, like the aldehydes that we are talking about. Some of them could be organic. Now, when you have these organic compounds, some of them are carcinogenic, and when they are inhaled, they are likely to cause cancer. So they can also be part of the particulate nature, these organic compounds. So the source of this organic particulate nature, organic particulate matter, is mainly two. One is, I've said, by incomplete combustion. When you are burning these organics and you don't have enough supply of air, instead of oxidizing the carbon to carbon dioxide and hydrogen to water, the compounds will break and form carbon particles, and these are the particles which will find themselves into the water. So we have things like benzene, we have rings like anthracene. So these are just cyclic compounds. Maybe we can draw the structure next time. And they are commonly found in coal. So when you see the dark part of product of combustion, then this one normally contains these compounds. That's why people are normally discouraged from taking a lot of roasted meat because of these particular effects, especially if the fuel is not clean. So they can be found in also cigarette smokes, coffee, and also burnt sugar for the organics. So so this is just to mention the same, that the particulate compounds can be gotten if combustion of the organics does not go to completion. So when it doesn't go to completion, then you are likely to form these compounds. The other problem that these organics can do in the atmosphere is that they can affect visibility. You may not be able to see far because of the particles. Sometimes they can scatter. I think we just saw the effect of photochemical smog, and we say the part of the products that we have there and the organics. So they can affect feasibility or feasibility of in the atmosphere, and this is also likely to cause other dangers, like if it's not very clear, we're also likely to have accidents and so forth. And then sometimes it can also be a source of bad smell. They can transmit unpleasant smell from one place to another. We are talking of things like paint, things like spray. And we also saw that when you have these particles, they can also cause what we call ozone depletion. We have just talked about the organics reacting with hydrogen peroxide to form further peroxide radicals and oxygen. So I think that's where this particular point is coming from. So to control this particulate nature or particulate matter, there's a technology which is called electrostatic precipitation. So this electrostatic precipitation uses ions to attract these particles and remove them from the atmosphere. So we have got what we call electrostatic precipitation, where we attract this and then they're removed from the atmosphere, but being attracted by the charges. Now for the hydrocarbons, which is also part of the particulate nature, we know we have two types for those of us who have done organic chemistry. We have the aliphatic ones, which are the straight chain, and then the aromatic ones, which are like benzene. So these ones, the sources are many. We can get them from volcanic activities. We can get them from forest fire. And the composition of organic matter can also produce these organic compounds. So those are natural processes. And then we have anthropogenic sources, which are human activities. So for the anthropogenic sources, the major source is from the engines, emission from the engines, vehicles, planes. When you burn these organics, they don't burn completely, and then you end up getting these organic things. And then you can also get them from industries, like the ones which make plastic, polymers. Pharmaceuticals can also introduce these organics into the atmosphere. So for the hydrocarbons, what are some of the effects of the hydrocarbons? So the beauty about these hydrocarbons, the aliphatic ones are generally considered to be safe. In fact, up to a concentration of about 500 ppm. The aromatic ones are the ones which are bad, the benzene ring. Those ones, their vapors are irritating, and they have also been known to cause cancer. So those ones are the carcinogenic. They cause cancer. And then we also have those ones like benzene with more than one nucleus, like this one, which is called anthracene and others. Those ones have also been known to cause cancer. So the concentration, they're normally allowed in very small quantities or concentration. So the concentration that's allowed is around 0.24 ppm per period of about 3 hours. So for plants, these ones can also affect the plants. How do they affect the plants? So they can affect the plants just the way they affect the other creatures in the soil. We know that when you have these organics, most of them are not water soluble, so they are likely to affect the plants by affecting the uptake of water and other minerals by the plants. So when you have the effect of this, if the plant does not get enough of this, will have damage of the leaf, the growth will be retarded, the size and the yield will be low, and so on and so forth. And then I think we also talk for this particular nature, The other effect is that they also take part in the photochemical smoke, which we just covered a few minutes ago, by interacting with nitrogen oxides and other compounds. So what is the fate of these compounds, the hydrogen, carbon, the organics in the atmosphere? So in the atmosphere, since they are emitted in large amount, the problem is they have got, although they are emitted in large amount, the beauty is that their lifespan is not that long. So I think there's an equation here which just shows what happens to the organic. Part of it we have shown, like for example, they can react with hydroxide radical in the atmosphere to form hydrocarbons plus water. The hydrocarbons can react with oxygen plus another molecule to form the peroxides plus the catalyst. So this one is just acting as a catalyst. And then the peroxide can even react further with nitrogen monoxide to form the aldehydes and nitrogen dioxide. And then you can also have this the organics also reacting further with oxygen to form aldehyde and water. So these are a reaction that involves generation of aldehydes. So there's a net equation given here where the hydrocarbon is oxidized. The net product is an alcohol, nitrogen dioxide, and water. So how do we analyze these things? So I think we analyze this compound using what we call a GC, gas chromatography. So there's a technique in chemistry called gas chromatography, where you hit your analyte, it's converted into a gas, and then it moves through a column, and then separation takes place. And when the separation takes place, the product are taken to a detector, which is able to tell us how much of this compound we have. So this one will tell us how much of the compound we have. Do you have any question up to there so that I don't talk to myself? Okay, so let us interact a bit. The funny thing with the online classes, you may not know is there somebody can log in and okay, so I think that's what I want. Yes, okay. So any question, any clarification?
These equations I can't understand for removal of hydrocarbons from the environment. The equations.
In the earlier one. Hello? In this one, sir, or in the earlier one?
Let's see for the fate of hydrocarbons in the environment. Now those equations for removal.
Okay.
I don't see what the reactants are, products are, as in I can't see the arrow to show that after this and this you get this. I'm not
there's
understanding.
a problem. Yeah, I get. There was a problem with the notes. I think the arrows were left out. Let me just show the cursor. So let me just start here. So you have RCH3. These are hydrocarbon. So it reacts with OH. There's an arrow between. There's an arrow between. You see this OH and this other. There's supposed to be an arrow here. There's supposed to be an arrow. And there's supposed to be an arrow. So these are the products. These are the reactants. So you can see in the product side, you have 4 hydrogens. Here you had 4 hydrogens. You have 1 oxygen. The oxygen is here. and the R is here. So there's an arrow which was left, and then we are supposed to have that arrow here also. So there's supposed to be an arrow there, and then an arrow is supposed to be here. So there's an arrow which was left between the equations, which you can just put and see. Okay, but just try to go through and see. I'll try to send you now all the notes, maybe today, after this, so that I don't forget. Dennis, are you there?
Yes, Prof.
Okay. So, okay, so let us interact. I think it's good if we can interact. I wanted to put the class in the morning, but some people felt it was not, they were not comfortable with that. So any question? Any question?
Yes.
Uh-huh.
The cut you posited has no marks.
Yeah.
And it is
It's long. We wanted it, maybe I'll give you some information where you can be able to get what you need. What I told one of you is that instead of typing, you can and write, and then you scan and upload as a PDF. Why I did that is because we started late, so I wanted us to do a quite a long one, where you can be able to get the info, but I'll send you some more information which you can access, just to help you answer that. And then see, I know it's quite long, but I thought maybe we do it for the purpose of helping us revising and getting through the notes. So this organic, the environmental chemistry is a bit general. It's not like the others, the stuff. Some of the things we can be able to apply general knowledge. There are things that we may need to go off a bit, like when you are trying to explain the gases, the formation of metals, how do they cause pollution? I think we'll find ourselves going a bit out of this, but I have the notes. I'll just send you as a package shortly where you can refer and get the information. Let it not worry you, but just use it for revision. I know some of the things we have not done, but you can just be able to read in advance. I'll give you some materials on that. I don't know if that's okay. Okay.
I also
maybe
had the same concern because there is somebody
yes,
who
yes.
said that you agreed in the last lesson that those questions are for revision and you will post another card. So
Okay.
I don't know.
Let me, but just try to see what you can do. How many questions are they?
40.
There are 40 questions.
Na iko na
There are 40
A,
questions, eh?
na iko na A, B,
But
C.
some have already done submitted. So I don't.
Some si wengine pia wafanye kama wengine tu. If some have submitted, I'll be fair in the marking, eh? I'll be fair in the marking because we started late.
It's okay, Prof.
Yes, thank you.
We'll appreciate if you send us more materials.
Let me send what I've just discussed, eh? Plus, let me just send what I've just discussed, and then we see. Sorry, I traveled a bit. I'm feeling a bit tired. Can we just stop there for now? And then, so when do we meet? Can we meet tomorrow or on Monday?
Yes, tomorrow.
Same time, 7 to 9.
Tomorrow. Let's meet tomorrow. and then we can discuss about Monday. Okay, thank you.
what
Let me
time?
just leave you. Can we do 7 or 7:30? 7:30 to
Morning.
9:30. Not
7 is
morning.
okay.
Okay.
Evening is okay, isn't it?
Okay.
Or 7.
Evening.
7, 6.
Evening.
Okay, or 6 to 8.
Yes.
So 7:30 to 9.
Now options.
7.
So or we just say 7 to 8:30, 1.5 hours.
Is okay.
Okay.
Better.
So okay, thank you. Sorry for coming late a bit. I was ending a jam. So let me just send right away. If I forget Dennis and Kimtai, just remind me, but let me just try to send it right away to your email. So thank you. Let's just stop there. Have a nice evening.
Thank you.
You too. Thank you.
Thank you, sir.
Thank you. Thank you. Bye. Bye. Thank you.
Wewe mmechoma, mnasema mshafanya bana. Ai, mungenyamaza hiyo kitu itolewe.
Kuna mtu anajiamini bwana. Sasa mimi na complain kwa WhatsApp, watu wanasema tushafanya. Tufanye tu.
Hiyo unasikia fair, usione kama ni fair. Hakuna kitu naogopa siku hizi kama lecturer.
Tafadhali next time discuss kila mtu yake kuna lot